Good afternoon, everybody. I'm Marco Raglianti, and today I will present this talk on research code as infrastructure. As a community of researchers, we produce different amounts of code. And let me start by showing some of the results of the brief survey that I shared with you yesterday. In total, 13 people replied to the survey with different roles. There were also multiple roles because we were considering a span of 3 years. So people probably started as master students and then became something else, also professional developers or research assistant and so on. What was interesting was that these 13 people in 3 years produced 29 tools, 29 research tools that have written themselves more than 50% of. And these people also supervised more than 24 research projects. If we have a look at for example, at the fact that we have only one professor replied to the questionnaire, and we have more than 10 supervised projects, the replies are quite easy to match in that sense, but it's still striking that at least one tool was developed by 5 people, and one person also developed 7 tools in the last 3 years. So research code is important, and it's important as an infrastructure for our research careers and research in general.
According to Wikipedia, infrastructure is composed of public and private physical structures, for example, roads, railways, bridges, water supplies, electrical grids, all those structures that are capable of enabling and sustaining or enhancing societal living conditions. Basically, as a society, we need infrastructures. Then, what do we need as a society or a community of researchers? We need a similar infrastructures, and the source code we produce contributes to such infrastructure. But how we produce this infrastructure? Like in the book and essay from Raymond, The Cathedral and the Bazaar, I think there's a third alternative which is often the case for research code, which is the cathedral, the bazaar, and the shack. When it comes to the shack is usually thrown together as a prototype, and it's never thrown away. As Fred Brooks suggests in The Mythical Man Mount, you should build one to throw away, and this is not what happens with the shack metaphor. Moreover, code quality is usually proportional to the distance from the deadline. Since the prototype is thrown together usually by deadline pressure, this reflects in the quality of the code that's written for the prototype as well. And finally, when the research code enters maintenance mode, usually it's equal to putting it into power-saving mode, because we don't have, as researchers, the necessary means and the resources to keep up, as it's usually the case when the prototype is beyond the event horizon of a publication that has been already submitted.
Here, I would like to set up a little bit the context with my limited experience, where, for example, I excluded postdocs because I don't have a real grasp of what happens in that case. But we have 3 different case studies: bachelor student projects, master student thesis, and PhD research tools. And already these 3 different contexts are quite different in terms, for example, of time span. A typical bachelor student project is about 3 months, while master student thesis goes from 9 to 12 months, also considering a planning phase, and a PhD usually lasts for 4 years. So if we consider the scope, we have a progressively increasing and starting from a narrow scope, very focused, to a broader scope, which encompasses the fact that you have to defend a thesis in the end by having an overarching topic through the subject of your PhD. And in the same sense, there is quite a substantial difference in the tool produced by these 3 different roles, where, for example, domain knowledge at the beginning of a bachelor project is non-existent, while we expect that in the planning phase of a master thesis, the domain knowledge starts to build up and reflects in the implementation phase, in the second phase usually. While, for example, in a PhD, there should be an increasing domain knowledge where you become an expert of that domain. This is just a quick glance of potential limitations, and in particular, for example, the final rush for a master thesis, when we have to write the thesis and defend it, can impact the quality of the code. And also the fact that as a PhD student myself, I tend to be paper-driven as well. The focus is to publish or perish, of course, but already from this matrix, we see that there are many, many different cases where software code is developed here. What's our attempt at research code as infrastructure? I started to have this idea when we were working on a tool for a bachelor project, Eduardo Riggio's bachelor project, and this ended up being accepted at ICPC, and I will present that in 2 weeks in Australia. Basically, the tool is about conversation disentanglement. As Tara presented before, I'm also interested in instant messaging, conversations, and that as a source of documentation. So it was interesting to have this pre-processing step. Let me try to set a little bit the context. Here you have a bunch of messages that arrived in a channel, for example, in our Discord server, but these messages cannot be easily interpreted as they arrived, where, for example, a disentangling algorithm might reshuffle this and put this in a better sequence. But what we had in mind was that if we, for example, use the front end to color the discussion and to color code the messages pertaining to each discussion, also here it's easier to see that, for example, user 1 is discussing with user 2, which replies to him or her. User 2 then has a single message that doesn't have any reply, and then user 3 starts a new conversation by saying hi and asking a question in the channel. So we achieved this with a very simple architecture, and basically we have a classical backend front-end architecture where the front-end as the client that talks to a REST API, and the REST API talks to the disentangler to disentangle the messages. In particular, the disentanglement was already implemented, and we re-implemented that from scratch from a model in the reference literature. This is important, and we will see why in a couple of slides. The API is also very simple, and we try to be very minimal with this service. We have 4 endpoints, 1 just for statistics, so 5 in total. This original paper from Elser and Charniak is the one that actually implemented and fully evaluated the disentanglement algorithm. But this arrived up to 2023 with our paper, and it passed through Chatterjee and colleagues, where they applied the same disentanglement algorithm to Slack conversations. It was originally applied to IRC, and then Subash and colleagues applied that to Discord and so on. What happens? We found when we tried to implement this that there were dependencies from 2007 still in the code in the form of a precompiled binary. We spent some time trying to configure that. It was interesting, but not fun. And at the same time, while inspecting the code, which was available because the results and also the code were published, we noticed that there were several layers and the code evolved through time. So basically to adapt it to Slack and to encompass some of the features that Slack had available with respect to IRC, some layers were added by Chatterjee and Lamevsky. And this also showed up through different expertise from people who wrote this code. And in particular, many hands were uncoordinated because, for example, the original authors didn't have any chance to influence the evolution of the code there. So 13 years old original source code was still showing through the cracks of what we were trying to use. Luckily, we decided to go for a new implementation from scratch, but we had some problems. We wanted, for example, to evaluate our implementation with respect to the original one. So we had configuration problems, reliability of results problems, and also a general problem on how to evaluate this. In particular, with reliability, we had some problems with the parameters configuration, which we tried to remove by having a deployed version. So CODI is deployed online and tries to abstract configuration issues for who wants to disentangle conversations. We had non-standard and unspecified interchange formats, where the stratification of the formats coming from IRC to Slack to Discord and changing formats certainly took a toll. They passed through XML and so on to translate, and these introduced problems, also probably bugs in the final outcomes. Because, for example, the names of the authors were translated only in a part of the messages, because one step in the pseudonymization of the data set probably was required by some reviewers at some point in the process. So In the end, we also had to re-implement the principal metric that was used for the evaluation. And although we tried to implement that correctly, we still have to be clear that we are comparing with the original article with a metric that has been re-implemented. Then we tried to realize why it's important to have standards and how they impact the open science. For example, for CODI, we wanted to have a format that was encompassing modern platforms, where, for example, we have a JSON format that describes the platform itself, has a name for the platform, and unique identifier, and the name of the server or the instant messaging platform where the messages are shared, but also encompasses for modern stuff like mentions or replies. And these obviously didn't apply to the previous formats, but we provided conversion from and to these formats. And this was done, again, in the online service. This comes from a need that I also found in the SNF webpage, where we have this citation of research funded by the public should be publicly accessible as far as possible and free of charge. So we have an open science policy. If we look at another page linked from this, we have also an open access to publication, which says almost the same. So we have to publish in open access journals, and SNF is committed to it, and also open data. So we have open publishing, open access, open data. But what about research code? The thing I was able to find is connected to the recommendations, for example, for the NATO research journals, where it's important to they strongly encourage deposit and manage source code through version control repositories, GitHub and such, and also to be able to identify code revisions, to identify and provide details about code licenses. And similarly, in the science editors, they have a recommendation for rare exceptional cases. We are all familiar with the fact that in open science publication, in open science submissions, we should explicitly state when we cannot share data and why. And here is we should make arrangements for opening this data or this code not later than the revision stage. In the end, I found this interesting paper, which is from a totally different domain. It's from the Journal of Chemical Information and Modeling, where we can draw some interesting parallels, where, for example, the author poses a question which is somewhat provocative, and it's also replied in the paper, but requiring code will prevent those in industry and software companies from publishing. We already see that we are struggling, and we try to have special rules for to encourage submissions from industry. Some other considerations, but about code will quickly go out of date and will have limited value. We have publishing and maintenance strategies that we need to enforce, or at least to develop even more to address these kind of problems. New methods can be made available via web interface. This is very pertinent for CODI because CODI is deployed as a web service. And in the end, I will also highlight some recommendations. But the main problems are this service can go down. We can have privacy issues. For example, if you want to try and disentangle your conversations, you might be reluctant to send them to a service like CODI instead of using one that you cloned on your machine and you try that disentanglement and so on. In general, we are competing for grants, and releasing code will give our competitors an unfair advantage. This is also discussed a little bit in the paper. But then what about open science, open access, open data that we mentioned before if we care about the grants? But this is still a struggle, and I don't have clear answers for these questions. What I would like to try and send towards and start at least a discussion is that, to me, one good recipe is to want to deploy but share the source code. This sometimes is hard because probably the implementation of the tool you have in mind is not easy to think about as a service. but then it can help you, for example, in having a service that's usable from the get-go. At the same time, you share the source code, and so you allow everyone to install that on their own machine and work with that. When we publish something, we need to decide what we do with the code. Usually, if the code has been accepted as part of the replication package, we also publish that. So my personal take on this is that we should aim for public development after publishing, where, for example, we can think about a scenario where a new student comes in, he or she wants to focus on a previous project that we already published. We have a local fork. We develop in a sort of safe environment for some time, but still this has some problems, because if the thesis goes on for 6 months, we have a fork that diverges for 6 months, and then it can be a problem to merge that back in. So another possibility is to involve professionals to adopt a project. And here, I imagine the role of some code launchers to be able to be interested, and going back to the matrix where the novelty was not that much for some projects. Of course, those projects are still going to die, but at least we can save some in this case. And yes, and in the end, I think one of the groups, at least I know for sure, that hired some staff in the lab to explicitly do maintenance and optimization on the code. And this to me is also a good solution to try, and I would like to know how it went. Going towards the conclusion, I promised the data from the survey, and here they are. We are pretty good in that sense. We have tools, the 29 tools that we had, and also the 13 people. This is about the 13 people that replied. Their most obsolete tool, their oldest tool, can be launched in a matter of minutes or of hours. So we are in a pretty good state, although there is someone who says too much, which is still something that can be addressed. But more interestingly is that in the end of the total tools, this is the initial slide, we have that only one tool of those developed was sort of not in a good shape, so it was not working as intended. And only 2 of those supervised, for example, here one had from 3 to 2 and one from 2 to 1. So only 2 tools of those supervised were not working as intended. So apparently everything works. Although this is in stark contrast with something that Gatesy analyzed in 2009, the analysis of 5 years of 1,000 papers revealed that 60% referred to a tool, but only 20% were installable. So probably as a software institute, we're doing way better than back then. I want to leave you with this, because to me, this is still the possible solution. And when you lose interest in a program, your last duty to it is to hand it off to a competent successor. Thank you very much.